plus 2. Whatever it gives to you, that serves as your remainder. What is the answer? What is the answer? X raised to power 4, that is 3 raised to power 4, because I've gotten our x to be 3 here, minus 3 into 3 square, close the bracket, minus 10 into 3, which is the value of x, plus 2. Solve this out and tell me your final answer. Take note, 3 raised to power 4 does not imply to 3 times 4. 3 times 3, 9, times 3, 27, times 3, that should give you 81. Minus 3 times 9, because 3 raised to power 2 is 9. Open the bracket, 3 times 9, that gives us 27 here. Minus 30, plus 2, 26 is the answer. So instead of solving that long division before we arrive at the remainder, we use what is known as the remainder theorem. Only when the question is asking you to look for the remainder alone. Don't bother yourself solving until you get to the remainder. All right, one more example or two more. Okay, let's assume you are asked to divide it by this. Look at this, 2x minus 3. What is going to be the remainder? Or let me change it to minus 1. It will be easier. They've given us the divisor to be 2x minus 1, and we're asked to look for the remainder. What is it going to be? Make x the subject of formula. Whatever value it gives to you, substitute. This is what I'm saying. From here, 2x minus 1 will be equals to 0. 2x will be equals to 0. Over here, plus 1. 2x here is equals to 1. We are looking for x. Divide both sides by 2. X is equals to 1 over 2. So you substitute here. So it's going to be 1 over 2 raised to power 4 minus 3 times 1 over 2 square minus 10 times 1 over 2 plus 2. Tell me what it gives to you. That is straightforward. Who don't understand? None. Good. If you don't understand this, you go back to your village. This very simple thing that I'm explaining here, what is it I don't understand? What is the answer? The remainder theorem. Only when you are asked to look for the remainder of a polynomial. Don't bother yourself doing the long division before arriving at the remainder. All you need to do, use the remainder theorem by substituting the value of x into the polynomial given to you. Then you solve accordingly. And we have gotten our x to be 1 over 2, which is also 0.5. 1 over 2 is also 0.5. So if you are the type that doesn't want to work with fraction, use it as decimal. 0.5 is also 1 over 2. Substitute into this polynomial here and tell me the value you would have. That automatically is your remainder. If you doubt it, give me the benefit of solving it all long. You'll see that we arrive at that same answer as the remainder. Who is true? None. Minus 2. I need confirmation. Go minus 2. Yes. I thought I heard sir. Minus 3.6. Minus 3.7. Y has is 2. 3.72 minus. Minus 3.2. If you guys cannot put in 1.5 into this thing as x and solve this thing, wahala dey o. They have given you the value of x to be 1.5. All you need to do is put it into this expression here and solve. Tomorrow now, when you come home, you say, "Jam, they are wicked. They you know pass, they fail you." If you can't do this thing and you expect to pass jam, Jam students. Well, if you are waiting for me to solve that, I won't solve that. Minus 3.7. At least we're supposed to have something like this. Minus 59 over 16. Right? I don't know how people got something like this before breaking it down. Right? Yes, that is what you are supposed to have. So all that say minus 3 point something is when they decided to break it down to what? Decimal. The least decimal. You're supposed to have this before breaking it down, that you have that minus 3 point something. All right. Let's look at this question as well. Last year question. The polynomial P of x is equals to x raised to the power of 4 minus 3x squared minus ax plus 2. It has a remainder. This is ax. It has a remainder of 26. We want to come back from down up now. It has a remainder of 26 after division by x minus 3. Find the value of a, or find the value of the coefficient of a. The polynomial P of x is equals to x raised to power 4 minus 3x squared minus ax plus 2. When divided by x minus 3, it has what? A remainder of 6. The question is find the value of a. I hope you know this happens to be the polynomial that we used initially. And a was what? 10. So it means I just did it on purpose so that we know if we're actually correct. It means by the time we solve all of this, we should be able to have a as 10. Because when we divide this polynomial of 10x by this, we got 26. Now they decided to remove the 10, but let's assume we don't know it was 10 that is here or that was here. So they want you to find the value of a. So solve it and see if we have 10. Very, very simple. You know from here, x minus 3 is equals to 0, x is equals to 3. So you have to substitute the value of x into the polynomial and everything will be equals to 26, which is the remainder. Then you can solve for your a. 3 raised to power 4, which is 81, minus 27, minus what? Here is going to be 3a, because our x is 3 already. So 3a plus 12, which is equals to the remainder. That happens to be what? 26. You can solve for your a. We all know that our a is going to be 10, but I only want you to solve it should in case you come across a question that we've not done at all, that you don't even know the actual value of a, you should be able to do that. But with respect to this question, we know our a is 10. All I'm expecting you to do is to solve and arrive at that 10 that happens to be the a. Very, very simple. I told you now, substitute the value of x equals to 3 into this polynomial. So we'll be having 3 raised to power 4 minus 3 into 3 square minus a into 3. Our x is 3 plus 2. Everything is equals to the remainder that happens to be 26. And from here, 3 raised to power 4 is giving us 81, minus here is going to give us what? 27 here, minus this one is 3a plus 2 is equals to 26. Collect like terms, solve for a. 10 is the answer. Why am I doing this? Irrespective of however the question might come, you should be able to do that. If it's a long division, for you to get your quotient, you should be able to do that. If it's the long division, for you to get your remainder, you should do that. If the question is asking for only remainder, no need of doing the long division. To save you the stress, to save you the time, all you need to do, use the remainder theorem. This is what we call the factor of this polynomial. All you need to do, make x the subject of formula with respect to the divisor. With respect to the divisor, make x the subject of formula. Whatever value you have for x, substitute that value into the polynomial itself. Whatever it gives to you becomes your remainder. You don't need to start solving afresh. And here, what they did, they gave us the remainder here, and they asked us to look for one of the coefficients. Very, very simple as well. Same method. Can I clean the board so that will move up? Can I clean the board? Can I clean the board? Good. Let's look at the factor theorem. Sometimes you might be asked to look for the factor of this polynomial. So you should be able to do that. Look up here. Objective question, very, very common to the JAM students. They might give you a polynomial, then they'll give you option A, a factor. Like, let me take this. They gave us something like this assumption. Let me just give you this. And they've given option A, x minus 2, B, x plus 3, C, x minus 1. And they're asking you, which of these is a factor of this polynomial? Which of the option is a factor of this polynomial? For you to know which is a factor, let's start with that. All you need to do, make x the subject of formula here. This will give us x is equals to what? 2. Substitute the value of 2 into here. If this polynomial gives us 0, it means x minus 2 is a factor of this polynomial. If it doesn't give 0, it means x minus 2 is not a factor of that polynomial. Do you understand? You move down to this again. This our x will be equals to what? Minus 3. You substitute minus 3 into the polynomial. If at the end you have 0 as the answer here, it means x here plus 3 is a factor of this polynomial. A factor of a polynomial must give you 0 as the remainder. A factor of a polynomial must give you what? 0 as what? A remainder. Listen to me again. For you to know which of this is a factor, you need to use what is known as PIN. Plug in your numbers. You start with this now. I'll bring this is x minus 2 equals to 0. As such, x is equals to 2. This 2 here, I will substitute into this polynomial. If it gives me 0, it means x minus 2 is a factor of this polynomial. If it doesn't give me 0, it means x minus 2 is not a factor of this polynomial. You move down to the next one because you are looking for the factor. Sometimes you might be asked, which of this is not a factor? Which of this is a factor? Do you understand? Now let's look at the first question. Question 1. Which of the following, writing, which of the following are factors of, which of the following are factors of, are we together? P of x is equals to x cubed minus 6x squared plus 11x minus 6. Which of the following are factors of, the person that said that should come again, I'm going over it again. Which of the following are factors of, they give us this polynomial P of x, close the bracket, is equals to x cubed minus 6x squared plus 11x minus 6. Let me give you the options so to guide us. Option A, x minus 2. X minus 2. Option B, x plus 1. X plus 1. Option B. Option C, x minus 1. I'll end it there. The third or the fourth option, I'm going to use it as a question as well. Let's end it there. Out of the 3 factors given to us, which is a factor, which are factors of that polynomial out of the 3 given to us? All you need to do, I told you, pick the first one that happens to be what? Is it x minus 2? Make x the subject of formula. It will give you 2. X minus 2 equals to 0. From there, x is equals to 2. Substitute that 2 into the polynomial they've given to us. If the answer is 0, it means x minus 2 is a factor. If it's not 0, it means x minus 2 is not a factor. X minus 2 is a factor. They say try others because the question says which of these are. So we might end up having more than one factor. Try others first and tell me how many are factors out of the 3 options. X plus 1 is a factor. That is, we've gotten 2 factors. Let's see if the third one is also a factor of that polynomial. X minus 1. So which is not a factor? Which is not a factor? They gave us 3 factors there. Make x the subject of formula. Whatever value you have, put it into that polynomial. If it gives you 0, it means it is a factor. If it gives you anything less than 0 or greater than 0, it means it is not a factor. A factor of a polynomial must give you 0 as a remainder. It must. Yes. Which is what? X plus 1. X plus 1 is not a factor. Is that what you are saying? So x plus 1 gave you what as a remainder? Minus Minus 26. As you got minus what? 24. You guys are funny. People cannot substitute single digit into expression and solve. Mathematics students. They gave us three factors: x minus 2, x plus 1, and x minus 1. Am I correct? Okay, give me the polynomial. X4, minus 6x squared plus 11x minus 6. This is it here. For the first one here, look up. For the is what? Here. And you are calling square. Now, here now, I have to make x the subject of formula. X minus 2 is equals to 0. As such, x is equals to 2. I will now substitute this 2 into this expression and see if it will give me 0 or not. Simple thing. 2 raised to power 3 minus 6 into 2 square, which is my x square, plus 11 into x, which is 2, minus 6. Let me see here. Here I'm going to have 8. 2 times 2 times 2. Here is 8 minus 2 raised to power 2 is 4. 6 times 4, 24. Plus 11 times 2, 22. Minus 6. Everything here is 0. So as such, this one is a factor of this polynomial. It means by the time we divide this by this, we'll have a remainder of 0. Even when we want to do a long division, that is what we'll have. That is what it implies. Let's check if this is a factor. Here is going to, I'm planing it to be 1 minus 1 raised to power 3 into minus 1. Here into minus 1. Who don't understand what I'm doing? From here, x plus 1 equals to 0. As such, x is going to be minus 1 here.